Okay, welcome. Today we're going to look at graphing our secant function. So go ahead and get your notes out and we'll get going. Alright, so the first thing we have to realize when we're graphing secant or cosecant is to graph these graphs, we're going to have to graph their reciprocal functions. Now secant is a reciprocal function to cosine, just as cosecant is a reciprocal function to sine. So just as we did in the other video, we're going to have to first rewrite this as it's using its reciprocal function. So I'm going to write exactly what it says, not going to change anything, but simply write, instead of secant, I'm going to write sine. So we have the sine of 3x minus 4 pi. Now, back up. What is the reciprocal of secant? It's not sine. I almost slipped up and mixed up our reciprocals. It's actually cosine. There we go. Glad we didn't do that. Okay, so now we're back to the right trig function. We rewrote it using cosine, and we're going to simply find all the points as if we were going to graph this. So we need the left endpoint, and we need the right endpoint. Okay, left endpoint is our argument set equal to the original left point of the parent graph, which is 0. And the right endpoint is the argument c equal to the original right endpoint, which was of the parent graph, which is 2 pi. So by adding 4 pi and dividing by 3, we get x is equal to 4 pi over 3. So that's two-step equation. Add 4 pi, divide by 3. Same thing on this side. Add 4 pi, divide by 3. We get 6 pi over 3. Or 2 pi. Okay, now we have our endpoints. Now we need our midpoint. Okay, our midpoints using the midpoint formula. It says if I take my left endpoint, add it to my right endpoint, I'm going to use 6 pi over 3 because it's the same denominator as my right endpoint, and I divide them in half. Now because we have fractions, I'm not going to divide by 1/2. I'm simply going to divide by 2. I'm simply going to multiply by 1/2. So when I do that, I get 10 pi over 3 times 1/2. And I can see I can cross cancel the 2 with the 10. And I get 5 pi over 3. And that's our middle point. Now normally we find our quarter points, but I'm going to hold off finding the actual values for those, because I want to emphasize how we actually graph the secant graph. Alright, so our next point is we're going to plot our points. Now 4 pi over 3 and 2 pi are on the positive side. So as I draw my graph, I'm going to skew it toward the positive side. I'm going to say, let's see, 4 pi over 3, let's go ahead and put it right here. And this is not going to be to scale, because 4 pi over 3 is pi over 3 past pi. The next one's going to be 2 pi, which would be somewhere in here, but I'm going to skew it out just a little bit so we can get a better idea of what's going on here in the graph. So let's call this guy 2 pi. And our midpoint is 5 pi over 3. Now I know we have quarter points and we didn't find the actual x values for those. We're going to hold off, but you would find them just like we've been doing it using a midpoint, except we have the right endpoint and the middle point for our two endpoints, and we have 5 pi over 3 and 2 pi for our other middle point that we would have to add together. So long story short, we have to find those quarter points using our midpoint formula on these two and these two. Okay, let's go ahead and find our amplitude. Our amplitude is 2, and there's no vertical shift, so I don't have to move these anywhere. So let's go ahead and call this 2, and 2 down would be negative 2. And because we're graphing cosine, we know cosine starts up at the maximum point, and then from there it starts heading down, and our first quarter point is a 0, and I'm going to use black for that point, because that's important. And then it keeps going down to our lower boundary at 5 pi over 3. And then it bounces back up and goes through our 0 at our next quarter point, and then finally ends up back at the max at 2 pi. Now, for this one period of cosine, I'm not going to connect the points. What I'm still going to use is use these points to graph secant. So I'm not going to draw the line, I'm using these points to graph secant. And I know that because they're reciprocals, anywhere that cosine is equal to 0, which is happening here and here, that its reciprocal would be undefined. So secant is undefined because cosine of 0 would be 1 over 0 if you took the reciprocal. So secant at these same points is undefined. And anytime we have undefined, that is an asymptote. The graph doesn't exist here. So I'm going to go ahead and draw in our asymptotes. Okay, now our max and min points, these are actually vertices to our secant graph. So if I think about what this looks like, the original cosine graph would be, let's put this in red, and I'm going to erase it, so don't do this on yours. It's coming down like this, and if I went over another period, it would start doing this. If I took the reciprocal of every one of these points, it would flip the graph up. So to graph secant, all I have to do is start over by the asymptote, come down, go through that maximum point, which is now the vertex here, and it would end over at the next asymptote somewhere over here. Same thing applies here. Our cosine graph would come down and head back up. So if you took the reciprocal, it would just flip this over. So start at the asymptote, come through, hit our point, and come back down. And then lastly, we have one more over here, same concept. The cosecant graph is coming up till it hits this point, heads down. If I take the reciprocal of every point here, it would flip it over. So for cosecant, start at the asymptote. The maximum point is the vertex, and we know we have a asymptote over here somewhere. And there's the graph of secant. Okay, if you have any questions, please jot them down, and I'll handle them when I get back to class.